Welcome you all to the lecture 4 and 5. This talks about spheres of energy, energy efficient, green, environmental, and sustainable designs. So we will talk about these. What are these? What are the differences and distinctions among these terms? We generally actually use these terms, but sometimes we end up using them at the wrong place because they mean actually something very specific. So in this illustration, you can see it is very clear over here. Green is the smallest unit of such like a sustainable design, and then comes the energy efficient, then comes environment friendly, and then comes the sphere of sustainability. So in this actually sphere of sustainable like a design, so there is an environment aspect with this green actually circle, and there is like a social aspects. So with the yellow circle, and these pink color circle represents the economic aspect of that sustainable development. And in this sustainable development also there are like two factors, one is the local context and the second one is the external context. So this is on the a landscape part. So we have been discussing about the a local context and the external context. So that is the one. And then even there are the things beyond actually the reaches of the sustainable design. So that one speaks of landscape and biodiversity conservation. Okay, so this actually comes at the level of like a bigger like a position, like a country, or maybe a very big region, like for example like Siberia or Arctic or Antarctic, or things like that. And there is even a bigger actually effort in terms of like the scope and reach of it. So that one is like a sustainable development and climate change mitigation. So in this one actually we deal with the situation at the global level. So at the global level, it becomes like the sustainable development and climatic change mitigation. So coming from the green one until the like a global level, so there is a huge range of it. So we should always be careful in what we are referring to and in what context. So it is very important for us to distinguish actually these terms which seems like overlapping. So let's see some observations by some researchers. So here Alvar and Clement Ekroon, they say they regard as sustainable intelligent building as a complex system of three basic interrelated issues, that is people, product and processes, and the interrelationship between them. So here you can see this ESE aspects of sustainability is spreading over here, and these people, processes and products are the part of this whole ecosystem, and they are encompassing it, because anything and everything we can associate within these three, like people being like us humans, and the processes means anything and everything which humans have created, and even there if it is existing like a the natural like a fashion. Okay, and the products what we humans are producing as a resultant of our like a growth and development model. So that becomes the part of this products actually category. So between these three, this entire like a ESE aspects can be actually encompassed, and we can establish with the help of their establishing their interrelationship, we can understand the phenomena which is happening at these three levels. So you can see like a people, products, and processes. So between these three, actually, this ESE it lies, and at the overlapping intersection of these three, the factor of like this sustainability actually comes into picture. So wherever we are able to satisfy the needs and requirements of these three all together at the same time, it becomes a sustainable model of growth and development. So that is what it means. This ESE is derived by even ISO as an organization. They actually produce like a certain set of regulations, okay, for the manufacturing sector, for our like a construction sector, for like a normal practices, okay, for like a manufacturing and everything. So they also categorize these sustainable like impacts in like a three: environmental, economic, and social. So there is actually a typology, okay, in like a buildings, if we particularly see in the like architecture. So there are like energy efficient buildings which talk about being good on the like energy. Okay, and then there is like a environment friendly buildings which talk about more than energy. Well, energy is just one aspect of the whole thing. So in energy, for example, when we consider like in other like electrical appliances or the home appliances, so they come with this BEE star ratings. Okay, so from 1 to 5, okay, they are rated on the star rating. So that rating is only for the energy savings. So if that particular product is complying the set norms of like energy saving, then it actually rated as is for like a 1 to 5 star actually rating, depending upon the actually the slab what the BE actually as an organization they have actually set for. So that actually slab also they keep on improving over the years. So if some product is qualifying for like a 1 star like at this year, so then the next set of like that selection, that 1 star may become the actually threshold of qualifying. So there may be some products which were actually designed by the companies which could not actually achieve even 1 star, and they were kind of declared not worthy for the market, okay, not worthy for the consumers to be like taken up to buy. So that is why they were actually not allowed to the like a market, and that's why we see these products whichever like areas like for example HVACs like air conditioners. So they come with these star ratings. Refrigerators, they come with these star ratings. Even computers also come like the US made computers. There is this energy saving star actually you may be seeing while when you start your personal computer. So in that actually one screen actually reflects at the beginning of the booting up of the computer. So these are all actually made for the energy saving means. So energy saving means is like a one of the aspects among the sustainable like practices, but there are like a lot many other things than just being like energy saving. So next comes like a environment friendly building. So in this actually category, the buildings they actually tend to be like a environment friendly. For example, they should not actually pollute. For example, every building like a building works as an organism. Okay, it gets born one day. Okay, it lives its life. It consumes energy. It excretes like waste. So it's a building is type of a living organism. Well, it's non-living thing, but it functions like a living organism. Okay, so there will be some waste. So a building as an organism must correspond to its surrounding, and that is what it means with the B, environment friendly buildings. The third one comes like sustainable building. So what are the distinctions from the previous ones to this one? Well, it's simply like it caters to the social and economic factors also along with the environmental ones. So the moment we talk like how one building is related with the society, well, there are new challenges which come up before the designer, before the architect and engineer, like how to design a building which is socially also responsible, economically also responsible, and obviously like environmentally also should be responsible. So now you understand the difference between like energy efficient building, environment friendly building, and sustainable building. So yeah, so here like green actually becomes a subset of the bigger set of like being sustainable. We saw in the like a first illustration over here, like a green is the beginning point. So maybe here you can refresh your understanding again. It starts with the green, then it goes to the energy efficient, then it becomes like environment friendly, then it becomes sustainable, and then the other two actually much broader actually perspectives come into the existence. So here in this slide, okay, it talks about like how we can go about consuming energy. So the first and foremost, the effort should be there to reduce the demand. Okay. So once the demand is like lesser, okay, we can exert actually lesser impact on the globe. Okay. So the reducing the demand should be the actually guiding factor while designing. Okay. So by avoiding actually like a wastage of like energy and materials and resources, okay, we can improve upon like a waste and the other like a wastage of the energy, wastage of the resources, wastage of the material, and all of those things. The second step in this actually progression in this concept actually suggests use sustainable sources of energy instead of finite fossil fuels. Well, of course, we know finite fossil fuels are going to last up to like a one actually fixed time, and by the time they exhaust, they may already have a crucial and a very critical and tremendous like an impact on this planet, because we all know like how much of emissions they actually generate. The third one, even if you still like a need energy and like a, for like a X amount, then produce and use that for fossil energy as efficiently as possible. So you must actually be responsible if you are using fossil fuels, because if you are not able to meet if you are not able to undertake your activities without this, but at least you should do it much more responsibly. So this is the actually concept of like a trias energetica. It talks about it here, like reducing the demand and then sourcing the like a infinite resources of energy instead of like a finite sources of the energy, and then using it efficiently. So these are the actually driving guidelines you can take in today's context, which become very relevant. So for like with the effort of like each and every of us, this is going to actually succeed. So for example, any like a one living like a house. Okay, so there are actually different components within a house, as you can see over here. If you take the example of like air conditioners, okay, so they are mainly used for like a heating or like a cooling and ventilation. So that is why they call like a heating and ventilation and air conditioning system. So if you are in a cold country, of course we'll be using it for the heating purpose, and if you are in a hotter country, we'll be using it for the cooling purpose. Okay, so this actually takes the major actually portion of the overall energy what we consume in our like buildings by air conditioning. So we must pay attention to like these HVAC unit to optimize, reduce and depend on the finite source of energy as much as we can do. Next, there are actually considerations like thermal insulations, because we may have studied in our like textbook, while we transmit energy, while we transfer heat from one place to another. Okay, even when we transfer like electricity from one place to another, there is always some percentage of like loss in that. Okay, so how that loss can be like minimized, how that loss can be actually kept to the minimal, so that because every unit of that energy is very important and it takes a toll. Okay, it has a lot of like impact on the surrounding. So by losing it, okay, simply we are wasting that much of like a resource. So that resource is very valuable, very critical. So how we can well minimize this, so that effort actually should be made over here for using like insulations, okay, in the like places, in the portions of the building where there is any chance of like a leakage in the energy. The next one, like efficient lighting, of course. So this change has come at least in India, like we are aware of, like we have moved on from the like incandescent bulbs to like a CFL based bulbs and LED based bulb these days. So they consume actually a fraction of electricity of what it was used by like an incandescent bulb. So the earlier these bulbs used to consume like a 100 watt per like a bulb. Now you can have thousands of like LEDs, you can run them in just 100 watts of like power. So this is a huge difference actually which has come, and but further it needs to be like reinforced. And ceiling insulation is part of that insulation. Thermal barrier, like again we have to check the transmission of like energy and heat from one chamber to the next one. So we should put it like a the thermal barriers, thermal like insulators in the places where the leak is possible. Even air barrier, the efficient windows, because windows are the actually portions from where there is they are the direct openings. Okay, so there is a lot of like sun energy which gets inside the sun's heat energy and light gets inside the actually interior. So how we can still receive the only light part and we can reduce the heat if it is not needed, then by putting up like a efficient heat reduction actually glazing, we can improve on this efficiency. And if we need heat, for example, if you are in a situated in a like a cold climate, so of course we need also need the heat also. So how the heat can be allowed in actually that scenario? Okay, so we can devise this actually glass in such a way so that it facilitates depending upon like a requirement in the interiors. And of course the mechanical ventilation is there to improve on the overall this thing. So with this, if you see, the insulation is one of the very important actually things. It becomes very important thing over here in the transmission of like energy, particularly if we talk about. So like how this envelops is the first step to improve the energy efficiency. The moment we are talking about energy efficiency, the first and foremost opportunity comes right in the insulation part. So here you can see in this it goes from 1 to 5, like performing like an insulation solutions in the building, as you can see from inside to outside. So the building surface, the building membrane, okay, is one actually element which interacts with the atmosphere, which interacts with the outside like a surrounding like atmosphere. So how we can insulate and save as much as we can. Air tightness and ventilation, okay, equipment and renewables. So these are the actually so these are actually some yellow colors is the performance, improving the performance of it, reducing the heat loss, okay, ensuring like a summer comfort, ensuring like a winter comfort. And these ones actually to improve the like air quality inside the the space, okay, for fresh and healthy air. And the next one talks about optimized equipment with good control and regulation. So this one actually talks about controlling the equipment and controlling the regulations of it. Okay, and the last one talks about it to like adapted to like a local conditions. So like how in the local conditions we can uh, redesign our like conventional like design like elements in the buildings, and we can improve upon this thing. Okay, on the last section, if you see here, like a related action, so the shape and orientation of the buildings can be like improved, so that to maintain the like this we saw over here, like how much of like a heat and radiation we are going to our building is going to receive in which direction. So based on that direction and based on the like a climatic situation and geographic like a conditions, we can reorient and reshape our buildings. Okay, so that is where actually the strategic actually design element comes into like a picture. So we as a designer, we as an architect and engineer, we can contribute for the efficiency while designing itself, because that is actually first and foremost actually step in the whole design process. Okay, till the like a delivery. Okay, that's so that we so that there is very little need of like a controlled environment, very so that there is very little actually need of the actually such efforts from like the external sources such as like electricity and these things to control them. The next one, orientation and the shear of the glazing. So this can be reduced to control the overall like a reception of the heat and radiation from the outside. Okay, shading, wind protection. So this can be utilized. And in the middle part, if you see, a good insulation of the envelopes of in terms of like a flooring, in terms of like a walls, in terms of roofing, windows and doors. So these should be like a properly insulated. Okay, for controlling like a heat. And thermal breezes treatment, air tightness, and also these are of course very important to reduce the like a convection and a conduction basically loss of the energy from inside to outside, or opposite. And ventilation and this. So in the renewable energy sector portion, if you see, there are some efforts in the recent decades which are made for like a photovoltaic cells, wind powers, biomass, okay. So these actually we use for like a, for example, these days the new concept has come up like a net zero energy buildings. So Indira Paryavana Bhavan in New Delhi, okay, in India, is the first net zero energy building which generates its own power, okay, more than 100%. So what it does, it utilizes its like a the power requirements from the site itself, and it supplies to the grid whatever the excess amount of energy they actually generate. So they are not actually depending upon the external sources such as like a coal and a hydel power and nuclear power, any such power, to get the receive the energy for their consumption on that particular site. Okay. So they are generating it by themselves. So that's an effort through which we can minimize the dependence on the grid. Okay, so once we are dependent, we are not dependent on the grid. Okay, we can generate our own like a power requirements, and even we can supply to the outside. So this is one actually sketch, you may have already seen it, like how with the location of the like a solar like a latitude and longitude, we can optimize on the efficiency of the design by orientation changing, by changing in the form, by changing in the overall volume, the materials which are coming in that particular actually direction, whether do we need like a heating or like a cooling. So depending upon that we can choose like a facilitating materials, insulator materials, or there's conventional like materials for facilitating that. So let's see like how the form of the building can be used as a, like a strategic input for designing buildings. So if we take this cube as a like a base case, So if cube is if this is like a holding like 100% of volume by like 100% of the surface area, okay, if in that case is one case like a base case, base unit case. So depending upon that, if we compare the other geometries, for example, this is a hemisphere one. So this is a hemisphere, okay, a circular base and a hemisphere on top of it. Now this is a cylindrical actually structure over here. So this has like a 96% of this quotient, this has like a 98% of it, and now this actually requires 112%. A pyramidal actually shape with a square base. Okay, and yeah, if we divide this same cube into like a smaller cubes, for example, like 8 cubes over here in a cube. Okay, so this also gives like 100%. The moment we again take out those cubes separately, for example, if we divide this building into like two different floors, like then it increases by 33%. It reaches to 133%. Okay, and the exposure increases to like almost double. Okay, in case if we are keeping these 8 smaller cubes which came from this block, okay, in a like a different place. So see how the requirement of actually is just got double. The requirement of the energy just got double. Okay, and in this one, if we keep them in a linear fashion, this is like a 142%. So there are actually you can see with this actually illustration over here, depending upon the form, shape, size, and scale of the building, the energy requirement of the building actually changes. So while designing, how we should be responsible, how we should be cautious about taking the decision based on the form and shape of the building is very important, because the energy consumption of the building is going to be there for all of its life on daily basis. So whatever, like for example, the embodied energy is used in the like production of anything, okay, so the operational energy will be very high. Okay, so the rate of consumption should be minimized from the design itself, design stage itself. That is the intention over here. So this actually slide talks about there is a direct relationship between geometrical shape and energy performance of the building. So it becomes very critical for us as a like a designer and architect to take care of this thing. So different results were obtained in this illustration, as you can see, in the energy performance of these masses which had the same volume but made in different forms. So they carry the same volume, but the surfaces actually got increased. Okay. In some cases they decreased, like in the hemisphere, if you see, it decreased by 2%, and in the cylinder also it increased by 2%. In the hemisphere it decreased by like a 4%. Okay, but rest of the others, since the surface area is increasing, so the energy consumption actually got increased tremendously. Okay, in this case actually, if you see, it got increased by like twice. So if there is a building block of just one bigger unit, and if we bifurcate, if we defragment that block into smaller blocks, it's going to exert a lot of like impact, a lot of consumption of the energy is going to increase. So that we should always like actually consider while designing our like buildings. So that is actually intent of this lecture over here, to give you the insight on this part. Let's move on to the next slide. And yeah, so how the location of actually our site, okay, of our building is also very important, that we have to understand with the like how the earth as a this soil as a material is behaves, okay, day and night. How the water body as a bigger mass of like a biggest mass of like a water behaves, okay, in the day and the night, and how the geographical like a features such as like a cliffs and valleys, they behave differently. So based on the actually the sun heat, okay, they actually get heat up. Okay, so the land actually heats up very fast. Okay, the water body heats up little slower. Okay, so the cycle of this, if there is a sun in the daytime, so the temperature on the land will increase very fast, but the temperature in the water will the water will start heating, and it will reach its pinnacle in the night time, not in the daytime. And further again, the coolings, when the cooling starts in the night time, the ocean, the water body will start cooling down, and it will cool till the daytime is there. So there is an overlap. So this actually, this difference in the property of this the heating and cooling actually creates actually the air movement. Okay, and this is one of the actually important reasons why do we have winds on our planet, because we have like a earth as a surface and water as a surface also, and the differential heating in them, it creates the actually low pressure and high pressure actually zones, and those actually are responsible for the wind movements. So we, while designing a building, we must take care of the ventilation. So in which direction the ventilating units such as like doors and windows and ventilation should be kept. So for that actually this understanding of this air movement, we must have to actually take into consideration. So if we have a house over here on this cliff, okay, so this is very important for us to understand what time of the day we want in, this ventilation, because this actually circle you see from here is moving like a clockwise, and this one is moving like anti-clockwise. Okay, so in the night time it's going to be have in such a way, and in the daytime it's going to be have in such a way. So it's different, and in a valley also you see it's reversed. In the daytime actually the hot air is rising from here in the middle, and in the night time the hot air actually is rising from along the surface of this valley. So it's completely like opposite over here in these two scenarios and in these two scenarios over here. So we must have the understanding of the topography, geography, and climate of any place, and the orientation of the like a sun and prevailing like a wind directions for actually planning our building. So this is one of the strategies which we employ at the beginning of our like a building designing at the concept stage and the design guidelines stage only. Yeah, and yeah, topographical effect as I stated earlier. And for actually facilitating actually an efficient flow of like light, heat, and ventilation, we have like a doors and windows. So we have actually a number of like solutions already existing with us, like how we can facilitate. So based on the width and height of these lures, okay, which are coming at the vertical and as a horizontal members, okay, the perforations and these pergolas, we can actually control the intake of light. So then in the summer actually sun comes at the top, and in the winter it goes little lateral at the downside. So the penetration of sun becomes like a more in the winters, and it reduces in the summer. Okay, so we can actually use this width of this actually unit over here to control like how much of like a sunlight I want inside the interior of the space. So this can be controlled over here, and of course with the number of like a fins in the like a windows. Okay, and if we want to carry the sunlight till inside the like a interior of our like so deeper inside where there is like a the deeper spaces, so there this kind of like a anidolic like a ceilings can be used where we carry actually light inside the like a spaces through like a highly like a reflective like a using surfaces. Okay, so these are the actually techniques through which we can uh, make it like a efficient use of like a lighting and heating in the buildings. And here as we see, I think we have seen in the previous slides, so how this material actually behaves, in like a certain like a atmosphere. So how it reacts, how it kind of responds to the surrounding. So if it is like a hotter outside, if it is like a colder outside, so how this material which is like a used over here, okay, in this actually building surface, depending upon the like a location of the sun and this thing it behaves. So that is the actually illustration given over here. So the ventilation and rods can be actually controlled from using like a such like applicable materials. And in internal gains, if you see over here, the gains from the like body heat, because humans as a like a, we also produce like a heat inside the like a spaces, and there is a load from like a lighting also creates some heat load. Okay, appliances, they produce heat, cooking and other like hot water activities and other like activities also like electrical activities, they actually generate. Even like our like computers and TVs, they also generate some amount of heat. Okay, and they contribute in the overall like a heating uh, like in the interior actually environment. And of course obviously there is like a solar gain. So we actually based on these calculation, like how much of solar gain is going to be in like a which month. Okay, because if it is like a summer, then the inclination of like a sun is like at to like a this distance, and if it is winter, then the penetration of sun is going to be little higher. So how we are going to control actually this thing? So depending upon this actually we can design our like a buildings and windows and fenestrations. Yeah, this is one actually example. Uh, so this shows actually the efficiency on like a two parameters. You can see here one y and this x dimensions. So this talks about like a structural embodied energy on the like a x-axis, and y-axis it talks about operational energy. So like this one is taken at the time of like a fabrication and manufacturing, and the first one is taken at the time of during the operation stage, as we have discussed, because the operations period is going to be quite longer, okay, than the time of the like at the time of the like fabrication of it. So both of these are like important. A huge amount of energy is invested in the time of like a fabrication also, manufacturing also, and a huge amount of energy invested in the operations also. So we must have a balance of this. So these cross sections, these cross points here, as you can see, these are the results actually observed from the different types of like these roofing forms and the geometry of this roofing. So there are a variety of like a geometric forms given to like this actually design, okay, and a calculation is made, and then optimized actually form is selected with this one, okay, to go ahead for the actually construction of it. And in the graph, if you see, this is here, right here. So this is a kind of a you can see an interplay of like a permutation and combination, where we choose actually a number which actually responds to both of the aspects, because both of the aspects are very important and should be actually taken care of. Okay, so I would like to show like a one case example over here. So you may be aware of actually, or some of you may have been to this place also. This has become a recent actually a tourist spot in the city of like a Singapore. Okay, where they have actually created an urban forest kind of actually structure. So this is supported by, as you can see, some these tree-like structures which are like a completely like man-made. Okay, so we will see, and you can see these people walking over here on the this like a footpath, and there is like an over the air like this bridge is there, so people are actually can walk in on top of these trees, in the middle of this height of these trees, over the top of these like natural trees, and they can have actually view of this area. This has actually water bodies and fountains and several other interesting stuff in the vicinity. You can see these creative actually shaped buildings also on the left and right side. So this is placed in a very posh area, very like a bustling area of the Singapore city. So let's see what are the actually features and characteristics of actually this urban forest, and how it behaves in the differently in the day and the night. So if you see here, so with the sun, okay, it has actually photovoltaic cell actually, and panels planted on top of it. They actually obviously they receive actually sun energy, and they produce actually electricity. So with that electricity, it actually sustains its own electrical needs, okay, to run actually this whole unit. Okay, so it has actually solar thermal collectors, and at the bottom in the underground level you can see over here. Okay, so the energy generated and collected is stored over here, and then it is further like distributed or maybe even supplied to the grid. Okay, so depending upon this, so they have actually all of these processes kept in the subsurface actually area, and at top they have actually even these moist air actually intake this thing, and with the help of these moisture in the air, they actually with the help of condensation they collect water. So this water they use for like, of course they collect water in the rain as well as this moist air, because this is situated in a like a oceanic area. So this is a very high like a humid area, humid regions it falls in. So there is a lot of like a water content in the air, and that is how they actually harvest water from these trapping this air, okay, this moist air in the filters. Okay, and yeah, and here in this last one, if you see, this hot air is pushed back again to the atmosphere. So they have this surface also such, so that it reflects actually the major portion of the light which is received over here. Okay, so there is a this reflects light, and in turn it creates a shaded area on the ground. You see this here, this shaded area. So it creates a comfortable actually shaded area on the ground. As what is done by the like trees also, they create a shaded area on the like, ground. They actually receive the sunlight, they do the photosynthesis activity. So on the same actually principle, this unit actually is undertaking several like activities of like the heating the water and electricity generation and gathering like a water droplets from the like a moist air and several activities, and in turn they are creating like a shades on the ground. Yeah, and on the night side, if you see on this shaded area, okay, the turbines, there are some small size like a turbines kept. They also create like a electricity from like a water shifting from energy generated in the day for the usability in the night time. So whenever there is like a movement of water which is collected on the top over here, okay, they have like a small size actually turbines installed in the stem of this unit. Okay, and that falling water actually falls on the fins of those turbines, and turbines run and they actually generate energy. So this actually garden, this urban forest, is one of the beautiful examples of like how the future is going to look like in the like a coming times. Okay, so in one of the like next lectures we will be discussing the future of the habitation, how the habitation is going to look like in the future. Okay, so it's really going to be one of the like amazing and interesting actually insights, like how we can actually conclude, how we can infer from the nature, how we can take insight from the nature and emulate them in our designs. Yeah, so you can see more close-up pictures over here. These surfaces are completely adorned with the like a these leafy vegetation and creepers and bushes and trees and stuff. So actually these greener bodies, they absorb heat. Okay, for example, you can go back in your home and in the next like a daytime you can experience, you touch a building surface in the sun. Okay, and you touch a wooden surface in the sun, you touch a plastic surface in the sun, you touch a metal surface in the sun, and you touch a plant which is exposed to the sun. Okay, you will feel different actually, the amounts of heat what they are holding, though they are like, receiving the same amount of like a sun's heat and energy, but how much they are how they are maintaining this actually balance, like a plants, how do they still keep their temperature, their surface temperatures low, is really an amazing fact. As compared to that, if we see our buildings, they actually get heat up very fast, and if you touch a building surface in the sun, well, you cannot hold it for a longer time because it's so like a hot enough. Yeah, and there are several other examples from across the world in terms of like a design and efforts being made by designers and architects and engineers from across the world to minimize that actually surface heat. Okay, they are using the same those natural materials to minimize that the surface heat. So of course, if this building was using like a conventional like a roofing, like for example like tiles and concrete or brick or anything, okay, it was definitely going to be much hotter than what it has now. It has like a grass cover. It has like a earth material, the soil kept on top of it, and there is a grass actually grown on top of it. So obviously it's going to be cooler. So how it's going to help in the energy saving like exercises? It's going to exert very little actually heat load on the building surface, the building volume inside the actually that building, and in turn that will save a lot of energy. Yeah. So if we now relate these efforts with the UN SDGs point which we discussed earlier, so which are those UN SDGs point which are relevant for the efficient building design for like energy efficiency, for their like a sustainability, for their being environment friendliness and all that. So these many like we have like these sets of like UN SDGs you can see on this slide over here. They are directly related with the building design. Okay, a sustainable building design which actually takes care of like a certain these many like a UNSDGs directly. So the first one is the number 3, which talks about good health and well-being. So obviously buildings are the actually man-made objects in which we spend most of our lives, whether it is like a it is our home or our office or our like a factory, or maybe a cinema hall or a recreational place, or maybe railway stations. All of these actually things are buildings. Okay, so we spend a sizable number of our like a hours per day inside the buildings. Okay, so feeling like a good and feeling comforted inside these buildings becomes very important. The next one, affordable and clean energy. As we spoken of, saving energy through these buildings is very important. Decent work and economic growth. because these buildings are the actually drivers of economic growth, because in them actually we conduct our like enterprising activities and we produce actually results. Okay, the ninth one, industry and innovation and infrastructure. This is also directly related with the building activities, sustainable cities and communities. So obviously a group of like the such structures and buildings, they form a community, they form actually a social life. For example, a set of like apartments, okay, they actually constitute a society, and those number of like a n number of like society, they form actually maybe a ward or a sector of the city, and then there are n number of like sectors actually collectively they form in turn a city. Okay, so buildings are the actually unit of that bigger block which we call it as a city. And the next one, response, consumption and production. Of course, buildings consume a lot of energy and material and resources, so we must minimize them. And climate action. So of course, the buildings are like as we discussed earlier, they are the kind of like organisms which consume energy, which exert actually waste. They live actually, they die one day. Okay, so they actually contribute a lot to the environment. So how this climate action can be controlled? So this is, they are actually directly related with there also. And life on the land, of course, most of our buildings are on the land, so they actually impact, they actually create a lot of impact on the land itself. And obviously this can be achieved only with a good cooperation and all, because even for designing and for construction of a building, n number of like experts and people are involved. We need a financer, we need a like a manager, we need an architect, we need a contractor, we need a lot of like a manpower to construct that building, we need a lot of engineers to monitor and design that building for their structure, and have several other like building services, a lot of like n number of people. And of course we need the users who are going to live in them. Of course we need the people who will be maintaining them. Of course we need people who will be going to dispose them off when the building actually comes to the end of its life cycle. So all of these are actually efforts, and of course we need those people who will be supplying services to that city, for example like energy, water, sanitation services and all. So obviously collective actually effort is going to help in any actually scenario. So, well, I don't talk much about this slide, but I'll give you a hint. I'm talking about the city of like Amsterdam over here. Like how Amsterdam has come up to like a in a leading position for the other cities and other countries of the world to like emulate is like a really like a praiseworthy. As we discussed earlier, they actually give a lot of emphasis on the like a pedestrian movement, cycling, and clean energy resources, the recycling of the waste. They do not try to produce, even a single household actually they try minimizing their like waste generation on the daily basis and all that. So there is a lot of consistent and persistent effort in terms of all of these aspects. Okay, and that is how actually as Amsterdam has come up to this level after like so many years, and it's worth actually praising. So as a like a homework or an assignment, just like a assignment to you, maybe you can go back and search more for like Amsterdam and what are the like a sustainable activities they have promoted over the time. Yeah, and for like any like a green office, these are the UN SDGs who are directly involved, like a good health and well-being and clean energy, infrastructure. And this we have discussed in the previous one, but this is specific to the office constructions. Well, there are some interesting insights from and examples and case studies from across the world. Well, of course, you may be aware of GRIHA and LEED, and there are like a CASB, BREEAM. There are many more actually sustainability assessment rating tools from across the world. Okay, which actually try to assess buildings or evaluate buildings or rate them on like a sustainability parameters. So, like there are several actually efforts being made from different agencies to design their buildings, in correspond to the these guidelines. So their actually work starts right from the conception and the idea generation and the design development of the building itself. As you can see over here in this building, you can see these wooden planks, they are arranged in such an interesting fashion. So of course it has become a piece of like an aesthetical value, but at the same time it is serving some other functional purposes also. First of all, it's creating an air buffer. I'm sure you can understand that. So by this crisscrossing, actually, this puzzle kind of like a structure, it's trapping air into it. Okay, and it's a kind of restricting the air movement on the surface of this building. Okay, and air is like a insulator material. So in turn, this is going to restrict the direct falling of the sun on the surface of the building, on the interiors of the building, on the glass surfaces. Okay, at the same time it's going to create at least a buffer, the air temperature buffer between the outside and the inside. Okay, so see like how like smart it is to use such a like a piece of like a work to have some multi-purpose like a functions. So apart from being just an aesthetic, it has some functional value also. And as the lead rating suggests for like this particular project, this is like a Japan house building from like Sao Paulo. So this has actually received lead platinum rating in the this latest year of like 2020. So this is really one of the very good examples. Maybe you can go back and search for more details, more such examples from across the world. So how these buildings can be actually made into a green buildings. So there are several efforts, several actually the corrective measures which can be taken in the different components, different parts of the building. Okay, so you can see in this slide over here, starting from the top. Okay, it has like a windmills, it has like a solar panel, it has like a green like a terrace garden on top of it. Well, terrace garden is an activity, is an like a strategy which reduces the overall like the heat, the heat component of the, because all of these building surfaces or in the concrete and brick and other materials, they generate heat. Okay, they trap heat, and they actually radiate heat in the night time. So overall, in the n number of buildings situated in any given like a city, overall they create a like a phenomenon of like a UHI, urban heat island effect. So collectively they radiate heat in the other times of the day also, and so they become kind of the whole city becomes like a very the heat trapping actually entity. Okay, so compared to the temperature, prevailing temperature in the countryside, the temperature inside the cities will always be higher because of this phenomena. And this actually feature of creating the terrace gardens on the top of the buildings is certainly going to have the impact on the minimizing actually that heat gain, actually overall heat gain of the city. So that is one of the strategies which we should apply in our designs to minimize the heat energy requirements of the building, as well as reducing the UHI contribution to the whole city. And there are several other like efforts which we can actually make. You can like a rainwater like a collection unit, like rainwater harvesting, because the rainwater is one of the biggest actually sources of like fresh water, potable water. So how well we can transfer it back in the ground, okay, for the like a groundwater recharge, or maybe you can utilize for like other sources. In some places like in the northeast, like I have lived in different parts of the northeast, so there I have seen like some examples. I myself have survived out for like for a few years on the like rain harvested like a water, even for drinking, even for kitchen, even for like all other activities, because there is no groundwater, because the whole place is situated on such a hilly terrain where it is very difficult to make a bore and take like a groundwater. So rainwater supply is the only supply which is easily available on like a free of cost. So you have your setting the design for the roof rainwater collection, and you have your unit to store that water and filter it, and you utilize it. So those actually techniques can be installed in all of our building. Obviously, Government of India has introduced and made it mandatory to have all government buildings and institutions and campuses to have actually rainwater harvesting systems. And yeah, and of course thermal insulations, allowing plentiful natural light inside the actually spaces, using actually energy efficient luminaires and other electrical appliances. So you can see there are like efforts being made in even in the interiors, in the energy consumption part, and even like non-toxic like materials and substances, so that there should not be like a VOCs, volatile or volatile organic compounds, emissions of the gases and such like a fumes inside the interiors, which will hamper with the overall the human comfort and well-being. So these many first, there are several more, you can explore more. We'll be talking more of these in the coming slides. So here if you see, there is an interesting relationship of a building with the society and the surrounding, like how a building is related with the like I said surrounding. So for example, like we get the supplies and resources from the trees and other like natural entities. These are bushes and plants, they actually help in creating where living a habitable living environment. there is a like a factor of like a social justice also, like how our society, how the people are empowered, you know how we are sourcing local and healthy food, how we can reduce the the indirect emission by not using so much of like the resources which are sourced from like a far away places or different other countries, you know life cycle assessment of the different like objects, and using like a local transportation, and again the energies plus atmosphere relationship. So any building is related with, of course, next to it like the next infrastructure, and that infrastructure is then directly related with the ecology of that place. So there are some actually exercises which are done for calculating like a life cycle analysis of like a products and buildings. So how much of energy they actually consume, okay, while they were like a constructed, while they were like a used, and while when they were actually discarded and disposed. So this analysis we will do more in detail in the coming like lectures, but you can look for it in the more details, like how these kind of efforts are being utilized from the design itself. Okay. So some actually this is actually climate analysis map, okay, of Chennai, of the city of Chennai in Tamil Nadu. So here they have actually given this wind wheel analysis, this wind rose actually diagram, and there is a temperature actually map for the entire year. So how much it ranges and what is the actually range, okay, and what is the prevailing wind direction. So based on this, actually these are the guidelines which we follow for designing our buildings. And of course, with the help of like recent technological advancements of the softwares and tools, we can have some simulation based results also, how our designs are going to behave in certain like circumstances, in certain climates, at the what time of the day, etc., how much of like a light intake, heat intake, and water supplies, and accordingly we can modify our designs, we can improve our designs. Okay, so I'll show some actually case studies, some very good examples which are actually commendable for their like effort, okay, from like different places. So this is an building of like a IOC, okay, International Olympics, like this thing, and yeah, so you see this has a very strange kind of design, but this strangeness is design is devised from the like a simulation, because at what time of the year, at what time of the day, okay, how much of sun intake, how much of light intake is needed in which portion of the building, and accordingly the surface of the building, the surface which you are seeing is tapering and waving off like that, okay, is actually designed with that actually calculation in mind. And this is one of the most efficient actually designs in the recent times. You can see actually the picture from other angle. So on the ground floor, if you see, okay, there is a continuity of this grass surface on the ground floor of the this building. So you see these windows and doors are lined up on the side of it. On top of that, there is a grass and actually soil and some seating arrangements are made. So in order to minimize actually that heat gain on the paved hardcore actually paved surfaces and tiles, okay, this was actually this arrangement was made. Okay, so maybe you can look for more details, more such examples from across the world. Okay, like this is an example from like a Norway. So this is a energy positive office. So like this is the most sustainable actually such a kind of a building. Okay, which was designed in the like recent times. Okay, and well, the statistics you can read over here, but it actually employs like a photovoltaic cells, and it generates its own like a, of course the 100% of power, rather it supplies to the grid also, and they store energy, this electricity power for the using in the other time of the day, year and the months when there is a little water, little actually sun. So this is an amazing actually actually an strategy where we can store energy to use in the some other months also, not just in the other time of the day, but in the other months also. This is a one of the very praiseworthy actually design in the recent times. So this is from this is design is from Mexico. So this is next to situated next to a forest. Okay, so they have actually designed this smart forest city. Okay, so this actually accommodates around 1,30,000 residents in planned covered housing. So this is this portion actually is a part of this whole actually scheme. So this with this scheme actually they have tried to go as close to the nature as possible. So you can see these this terrace gardening and fins on the surface of the building, and strategic actually, the orientation and form of the building is such that that it allows actually the light, heat, and visibility to the outside. This is one actually example in a very unusual form, like so it allows actually heat even from the roof, as you can see, so that in order to minimize the dependence on the electrical lighting as much as possible. And you can see the costing and all other details are given over here, like how much it has saved on the regular construction, like materials and energy consumption. This is one actually concept actually design. So this utilizes the tidal waves to generate energy. So I suppose this is still at the conceptual actually stage, but it has won an award, a prestigious award. Okay, and for its like how to utilize like the existing actually the natural energy sources which are present on the site. So this was actually created next to an oil rig. Okay, and there was a lot of like ocean waves surfing from the bottom of this actually structure. So accordingly, actually they have utilized to trap a lot of like tidal wave energy and turning into the electrical energy. And here in this one, you can see the grass surfaces and vegetation is wrapping around the building. Obviously, in overall sense, actually minimizing the heat load, you on the top of on the surface of this building by being present, everywhere. So this is creating a kind of a, the comfortable like air chambers on the surface of this building. So the overall heat actually load on this building has reduced significantly. Yeah. So as we have seen in the previous like slides, so there is always a kind of an effort on like a certain base. So there are if you see like integrated urban planning design and sustainable design principle. So there are four pyramids which are coming to form a bigger like a structure. So you can see these four pyramids over here separately. Okay, so the first one talks about the basics. So the function of the building, function of the design must always be like taken care of, because that building or that design is not actually going to succeed if it is not following its function. So the function, reliability, usability, proficiency, and creativity comes the last at the pinnacle, but it contributes also the most. In the system design principle on the left hand side, you see it starts from there: flexible design principle, universal design principle, inclusive design principle, user experience. So these are all should be part of the overall like a design actually effort. And in the bottom one, you see it starts from the like a Maslow's principle, you may be all aware of, like how it corresponds to this Maslow's principle, Maslow's pyramid also, like physiological needs, safety needs, love needs, self-esteem, and self-actualization. When we think on like a reflecting on our life and the overall life and this thing, productivity. On the right hand side, it starts from the bottom up planning approach, then it goes to community participation, because no design can succeed actually without the participation of its like people. Okay, and the next one, action oriented planning, okay, normative planning, and then advocacy and top down planning approach. So they are like interrelated. So these actually four pyramids are coming into the common confluence of like the three aspects of sustainability. So these three colored circles you see on the top of these four pyramids. Okay, so these four actually pyramids are confluencing into the sustainability. So this is the approach actually given by these field work in 2016. So this is one of the actually insights which I thought of like sharing with you, like how the designs can be part of the bigger the perspective from the life. Okay, and there are well various uh, domains inside these EAC aspects. We will discuss about these in the coming lectures. Okay, and how like environmental aspects are integrated, how in that like a technological aspects are like interrelated, and you can see over here, and in an kind of an integrative like a way, this is connected, they're all connected with each other. And this is how actually the life of a building or the whole design process actually evolves. So from the beginning, you'll see the client briefing standard, then analysis, and then the programming, then the design part, then the development part, the services part, the construction part, and then comes the other like end of the life stages part and all. Yeah, so there are different actually stages is the sequence is given over here of the design process of the sustainability and how it evolves, and some examples like as we discussed in the previously, like how the orientation of the building blocks should be kept and how the simulation and the analysis tools are helping these days. So this is a one actually researcher has actually given this actually figure which talks about like how about the like a winter valuation and how about the summer valuation and what are the values and the different actually places of the site. So they have actually created a grid, and based on that grid actually they are concluding that this should be the best location for the like a building form. Okay, and in 3D if you see like how the building form can be further bifurcated and defragmented into like a smaller forms. Okay, to facilitate of course this are the functionality as we saw in those pyramids. Okay, and of course the technicality part of it, energy saving part of it, and satisfying actually all of those parameters which a sustainable building actually serves to. So with this we have come to the end of today's lecture. Thank you very much.